Premium Hill Academy. Morality, ingenuity, and excellence at its peak.
Alright guys, let's look at Theorem 2 as regarding to second theorem questions, right? Theorem 2, it's a very simple theorem. I'm going to be showing you a simple step on how to understand how Theorem 2 works. Come with me guys. For instance, we have a circle like this, right? Let's assume this is a circle now. Although my circle is not drawn to scale, so just bear with me guys, right? This is a circle. And then we know that this is the midpoint of the circle. Let me illustrate with another smaller circle like this. Let me just illustrate another smaller circle. And let me draw another smaller circle again. I'm drawing two small circles to illustrate what I mean. If this is the midpoint of the circle, and we have a line running from any point in the circumference. A circumference is simply the curved part of the circle, right? Yes, it's the curved part, circular part of the circle. And if the line touches the circular any point in the circumference to the midpoint, this line is called a radius, right? So if we have, for instance, another line again from this side running to form an angle here like this, what's this line called? It's also called a radius, right? And together, we know that together they are called a radii. So we have one radius and another radius, right? And remember we said something in the first theorem. We said if we have a line touching the circumference and running to the edge again, another line running to the edge, and we have this line is called a what? It's called a chord. If it is coming from the middle, it's called a diameter. We said that in the first video, right? So if we have anywhere in the line, let's assume the line is coming like this from here to here, this is called a chord. And we have another line again running here. This line already is called the chord because the chord is a line that cuts the circle but not from the midpoint of the circle, right? If it cuts, like remember the orange and the orange cases we use. Remember we said if the line cuts the circle from the midpoint, it's called the diameter. And if it cuts it from anywhere else except the middle, it's called the what? It's called the chord. So look at this now. It is cutting this circle from here like this. It's cutting the circle from here. So we have one chord. It's also cutting the circle from here. So we have another chord. We are going to be applying these two into forming one theorem. So look at now. If we have the line, let's assume we have our radius, this is our straight line, and we have another radius as another straight line, right? And from this point of the chord, we have a chord, right? And we have another chord again, like this. Sometimes we call this theorem the arrowhead theorem. That's the spearhead. You know how a spear is like now? An arrow is always like this. So somehow like this. Sorry, I know mine is not drawn to scale. An arrow is somewhat like this, right? But that's not what we're looking at. Right? So look at now this theorem. What this theorem means is that, remember, this theorem is only formed when we have an angle formed at the middle and an angle formed at the edge. And the edge can be anywhere in the circumference. So we have one arrow at the edge of the circumference and one angle formed at the midpoint. Look at one angle formed at the edge. Let's call this E, right? Edge, let's call it E, and let's call it what? Midpoint. Let's call it M as midpoint, right? So you understand it with simple term. What this law means, what this theorem means, is that the midpoint, the angle at the midpoint, is equals to twice the angle at the what? At the edge. Just know this. If you know this, we are easy to solve this question. You can apply it to any question we want to solve. The angle at the midpoint is equal to twice the angle at the edge, right? So we are safe to write it like this. Theorem 2 can be, we can say Theorem 2 equals, right? And then we said angle at the midpoint, angle, this thing here, it's a short form for angle. Angle at the midpoint is equals to angle, that's 2 times the angle at the what? 2 times the angle at the edge. If you know this theorem, you are going to solve any question as regarding to what this theorem entails. And in this tutorial class, I'm going to be giving you maybe 5 to 6 examples as regarding to all of this theorem. I'm going to give you 5 to 6 examples as regarding to all of this theorem. Come with me. Welcome guys. It says, the question 1 says, find the value of angle ACB in the diagram. Look at, how do we know what this thing means? Let me try and explain what this is. Angle ACB, what it means is angle A, the middle angle. When we have 3 numbers here, the question is asking us to find the middle angle that A makes with B. Are you getting this? So when we have angle ACB, it means this straight line, they are forming an angle, the mid angle, that's this angle, A, C, and B. So what is forming AC and B is this middle angle. So that means we are looking for X. They're asking us to find X. How do we do that? Remember the theorem we said when we have a spearhead angle like this, we said this part, look at it, say the midpoint is equal to 2 times the angle at the edge. So what does it mean? It means that this angle will be equals to 2 times the angle at the edge. And what is this angle? It's called x. So how do we find it? It's very easy to solve. So solving this angle, it becomes 60. Remember the formula? We said the angle at the midpoint is equal to 2 times what? The angle at the what? At the edge. Right, so we can solve this question as simple as it can be, right? Look at now. So what's the angle at the midpoint? 60. So angle at the midpoint is 60 degrees. Is equals to 2 times, what's the angle at the edge? X. Look at the edge here. That's 2 times x. 2 times x. So how do we solve? It becomes 60 degrees is equals to 2 times x is basically 2x. What do we do? We divide both sides by what? By 2, because 2 is the coefficient of x. Therefore, we can say that 60 degrees is equals to 2x. Dividing both sides by 2, we know that 2 will take off 2 here because they have the same value. 2 here is 1. 60 divided by 2 should be what? Should be 30. 30 degrees, that means x, the remaining value here, x is equal to 30 degrees. That's what it simply means. We have an angle like this. We are meant to solve the other angle, knowing fully well that this angle is twice the value of this. That's the only and that's the simple answer to this. Let me show you another question as regarding to this question. Okay guys, let's look at the question number 2 on the board. It says find the value of x degree in diagram below. Look at this diagram now. In this question, 2 theorems are forming here. The first 2 theorems are forming here. If you look at, just observe. The first question, look at, there is a radius here and there is a radius here. I will note that if 2 radii are forming at the midpoint, they have to be 2 chords that is forming here for us to get an angle here, right? Look at the first theorem. Remember that we said in the first theorem, if we have an angle touching like this, let's assume that okay, there's one touching like this, and then we have another one touching like this, right? If we have 2 angles forming at the circumference, this angle x is equal to this angle x, right? So if we have this angle, anywhere you see that 2 circumferences, 2 angles are forming at the circumference, whenever you have here is what you have here. Now we have only one here. That means we have to form another one, which is giving us this rule, so that you can find here, whatever we get here is what we have here. What do I mean? Look at what I mean. I said if you can look, just trace an imaginary line to form another one here like this, right? Look at, I'm just trying to form another one like this. And if I try to cancel this one off, you see that you just have this equation, which is the second law we talked about, that this angle at the midpoint here, this angle, this one is equal, this one is twice the angle here, right? I'm sure you understand what I'm doing. The angle was given, but for us to get this value, we need another one such that the 2 circumferences are touching. And from here, we can get our theorem 1. That is, if I cover here, and we have, look at 2 radii forming at the middle, and then 2 chords forming at the circumference, right? Such that if you can safely find this question, if you can get this one, we already know what this one is. Because whatever we have here is what we have here. Why? Because the 2 chords are touching at the circumference. The 2 angles are forming at the circumference. Right? So what do we do? Our duty now is to find this angle at the midpoint. We don't know what it is, right? So let's just call it something else. Let's call it an angle y. Let's call it an angle y degree. And then we know that angle at the midpoint is equal to what? 2 times the angle at the edge, right? Look at, we already have the first theorem forming here like this, right? Angle at the midpoint is equals to what? 2 times the angle at the edge. So we can form this question. So our solution strategy, our solution therefore will be the angle at the midpoint. Look at the midpoint here. Angle at the midpoint is equal to 2 times the angle at the what? At the edge. So what do we do? Look at, angle at the midpoint is 126. That is 126 is equal to 2 times, what's the angle at the edge? We don't know it, so we are looking for this angle at the edge. Let's call it y. 2y. I'm sure you understand what we're doing. So that 126 will be equal to 2 times y is what? Is 2y. And so we will divide both sides by what? Right? Therefore, 126 is equal to 2y. We divide by 2. 2 we take off 2 here, right? Yes. And then what comes here? 126 divided by 2. 2 here is 1. 2 into 12 is what? Is 6. And 2 into 6 is what? 3. Therefore, we can see that our y degree is equal to what? 60 what? Sorry. It's equal to 63 degrees. The value of y is 60 degrees. So what we have here is 63 degrees. I haven't done that calculation. Remember here now, 63 degrees. But we know from theorem 1 that any angle forming at an edge is equal to the angle of another one forming at another edge in a circumference. That's what we said here, right? If we have something like that, we are seeing an angle at an edge, an angle at an edge. That means this angle 63 is equal to this angle. Therefore, we can safe to say the value of x degree is equal to the value of y, which is equal to what? 63 degrees. It's that simple. So what did we just do? Finding this angle, they didn't give us this one in the first place, right? This one was not given. This one was not given in the first place, right? This angle was not given. This was how our question was looking like. So what did we do? Simply, we had to, using by manipulation, we have to form another line. Look at how the angle was before. It was like this, just like this. Another one forming like this, right? So we had this midpoint angle, right? We are asked to look for this angle, but we don't know what this angle is. So imaginary, let's just imagine as if we don't have this angle, for instance, as if we don't, and we have here as 126. So what do? We simply form this angle so that we know that getting this angle is not hard. The angle at the midpoint is equal to twice the angle at the edge, right? So if we can find the angle at this edge, and which we did was 63 degrees, we know that this one that was given originally was here like this. So if we remove this one, what can you see? You see we are forming theorem 1 again. Whatever is here is equals to whatever is here. That's 3 degrees. That was how we got the value of y. I'm sure you got something in this class, and I know it's not hard. Even if it is hard, you can go to the comment section and ask me a question there. I'm still going to be breaking the question down for you. And if you think this question you don't understand this more, I'm going to show you another video in this slide. Come with me, guys. Right, guys, still on the question on theorem 2, how to solve questions as regards to theorem 2 problems, right? Look at this now. It says in the diagram below, find the value of y. Now we're going to look for this angle y. This angle is simply something like this called an isosceles triangle. This is an isosceles triangle. So how we're going to be solving this question is that we're going to be tracing it from the very root. Now how do we do that? Look at, in solving this question, we know that this is a triangle. This is a triangle. This one, like this, is one triangle, right? So I'll be assisting you in drawing it. We have one triangle like this, a circle, and inside the circle is a triangle like this that I just showed you now. And the triangle, this part of the triangle is 35 degrees. This part of the triangle is 20 degrees. So what should we be doing? We should be looking for this angle, right? Because you have to know what this angle is. The sum of angle in the triangle is 180 degrees. That means we are looking for this angle. Question. Are you seeing inside the triangle? We're looking for just this angle. That's what forms this triangle. And in doing that, it's going to be what? 35 degrees plus what? 20 degrees plus what? Plus x degree is equals to what? 180. The reason for summing everything to give us 180, it is because of the sum of angles in what? In triangle. Sum of angles in the triangle is 180 degrees. And so what do we do? 35 plus 20 will give us what? 55 degrees plus x is equals to 180. Of course, you know this operator does not support that we'll add these two. So we have to collect like terms, right? Collect like terms. And do that, what happens? We have that if this one crosses and comes here, x becomes 180 minus 55. And what should that be? X becomes what? 125 degrees. That's the value of x. So we can come here and see this angle is equals to 125 degree. But that's not all. What do we do from here? Look at this. Also is a straight line. This is a straight line that has a line like this. So we can find this angle now. This angle here. Let's call this angle x for this, or let's call this angle let's call it z. Let's call this angle z. Look at, so this is a straight line. I can come here and say this angle long here, this long angle is similar than this angle here, right? This long angle here, and this line is a line cutting the straight line into two. It's a line here, right? So I'm just bending it. So I know that this angle that we just found from here to here, that's a triangle. There was a triangle here before. We just remove the triangle to show that this actually is a straight line. We have 125 degree here. Our duty is to find this angle, right? Yes, from your preliminary calculation, you know that angle in a straight line, this is the straight line angle. What do we do? How do we find the value of s? We'll add this and this will be equals to 180 as well. This angle plus this angle give us 180. Therefore, you know that 125 plus x, that is from here. I'm trying to show how we get this angle now. 125 plus x is equals to what? 180 degree as degrees, right? So that our we can't add, so we have to collect like terms, right? Collect like terms. So what do we do? X becomes 180 degree minus 125 degrees. Of course, x will become one what? X will become 55 degree. That's it. We call this z. Sorry, this is z. Sorry. That means our z instead of x is z, please. That's my bad mistake, please. That means z becomes 55 degree, right? So first of all, we got this triangle, which is this triangle, finding this angle, and then we're looking for this angle less as well, right? And getting this angle now, we now know what this angle is, that this angle is 55 degrees. But if you look at this triangle very well, you will discover that it is the first angle we've been doing. Look at two angles at the midpoint and two chord touching the edge. So I can redraw it like this. What I'm doing, I'm just trying to make it easier for you. That's what I'm doing. You now have two angles touching the edge, right, and two chord like this, right? And we know that this angle, that's the formula here, angle at the midpoint is equal to twice the angle at the what? At the edge. That's what we just see now. Although we have a line like this, I'm going to explain this later. I'm taking it step by step for you. There's a line like that, but leave this line out first. Right, so how do we find this mid angle? This is the mid angle. How do we find it? We know that the midpoint angle, let's call this our midpoint. Let's call it P, or let's call it M, since we know it as M. Midpoint angle is equal to twice the angle this, and we just got the angle here, which was this Z. Look at, we just found the angle as 55 from what we've been doing the calculation. That was why we are looking for this angle, using this triangle to find the angle in the straight line, because we cannot get this angle if we don't know what this angle is. You get? So that's why I'm getting this angle. We have to look for this angle and then using the angle in the straight line to get Z. And Z is this is Z, which is 55 degree. If you look at it from the triangle, from the circle, it's 55 degree here. So what do we do? You know that this angle M, look at it, angle at the midpoint. Angle at the midpoint is equal to what? Twice the angle at the what? At the edge. Right? So what's angle at the midpoint? M. Let's call it M. Is equals to 2 times what's the angle at the edge? 55. Now we know that the angle at the midpoint is what? Is 110 degree. We now know this angle now to be 110 degree. Whenever you say it's 110 degrees, right? Safety to say that this is a triangle. If you look at this is a triangle. If you look carefully, it's a triangle that we have here, and it's an isosceles triangle. And what's an isosceles triangle? An isosceles triangle is a triangle whereby we have just two angles equal, two sides making two angles equal. That means whatever angle is here, if we have here, it's the same thing as what we're going to have here. Right? So if here is y, it means that here will also be y. What does that mean? It means that in a triangle, if we have this as a triangle, an isosceles triangle like this, if this is our isosceles triangle, we've already gotten this angle from here, which is n, and m was what? 110 degrees, right? So for an isosceles triangle that we have there, this is 110 degrees. So what becomes of it now? I hope you're getting what we're doing. So if this is at 110, We have here as our what? As our y from here. And then we have here as our what? As our y we are looking for. So how do we solve this? We know that our angle is sum of angles in a triangle is equals to 180 degrees. So it becomes 110 degrees plus y degrees is equal to 180 degrees. Right? So we can say 110 degrees plus 2y is equals to 180 degrees. So we can say 2y is equals to what? 180 degrees minus 110 degrees. I'm sure you understand what we're doing. So you can say 2y is equals to what? 70 degrees. And then we divide both sides by what? By 2. So 2y, which is equal to 70 degrees, dividing by 2, we take off 2, y becomes what? 2 here is 1, 70 divided by 2 is what? 35 degrees. That's the value of y, because the question says in the diagram below, find the value of what? Of y. So what did we just do? The diagram was given. We're not giving this angle, we're not giving this angle, we're not giving this angle. Right? Our duty is to get to this triangle, and this triangle is forming our theorem 2 already. If you check well, if you try to remove every other thing, you see that the theorem 2 that is forming, and from the theorem 2 there is another triangle inside. That's basically how second theorem question works. You have to connect the dots. That was why in the first video, if you go down to the link below, if you go back to the description box below, you will see the link to our first video there, right? That's why I was teaching you guys that in the first video, I have to teach you what triangle is, how to solve triangle questions, how to solve angle on a straight line, right? That's why I was taking you on those journeys, to see how we can easily solve those questions if in case we see them. And we're going to be seeing more of questions like this, right? More of questions like this are going to be coming. So we have that question given. First of all, what you should do in solving second theorem question is to look for the dot. I told you second theorem is looking for how to solve the angle inscribed inside another angle, right? So looking for how to solve any angle inscribed in a circle. So look at the circle now. Circle was given. Our job is to find this angle from this triangle, which was this. So we named it x. Having gotten x, we can now draw the angle on a straight line to find this angle, and we named it z. Right? That was z. Having gotten z, we can see now that we have that problem there. This was z. We just found this was our z that we found, which was 55. And you know what this theorem is? It's the theorem 2 that we'll be treating on. So 2 of this angle is equals to this angle. That's how I said the midpoint is equals to twice the angle at the edge. So the midpoint angle is equals to 2 times the angle at the edge. That's what gave us 110. So on getting 110, we have gotten our main angle, the first angle in our isosceles triangle. So in getting that, since here is 1 time, isosceles triangle is a triangle whereby 2 sides are equal. Right? So y plus y, just do this and solve. You see that it's very, very, very easy to solve. Right? I'm still going to be showing you 2 more questions on how to solve second theorem question. 2 more simple questions. So we'll be tackling them simple by simple. We'll be applying them to ourselves and see how we can get to there. Join me in the next video, guys. See you there. Welcome, guys. Let's look at the next question on the board. It's regarding to second theorem 2 question, right? And the question says, what is the value of the angle x, y, and z in the figure below? It's not hard. If you look at the question, I've taught everything, literally everything you need to understand. This question should actually not be a problem for you, looking at the question. So what does it mean? Look at, in solving this question, we already know that if we see two chords touching the edge, this chord 1, this chord 2, edge 1 and edge 2, it means that whatever is here is same as what is here. Therefore, we know that x is already supposed to 10 degrees. Right? Because the 2 edges are touching each other. So we already know that x is already 10 degrees. And so from there, what can you see? You discover that we have angle at the edge. Look at this angle at the edge. Let me just draw the triangle, the circle for you. Look at the circle again. You know that there's this angle. I'm taking this angle like this from A to B. Look at A to B. This is A. This is B. And then B to C. This is C. Right? And then there's a triangle, right? I already know that B is 10 degrees, right? And then there's another triangle here like this, which is angle O, and it's coming down like this again. We have taken this one off. We already know what this is. This one that is forming here, we're already taking off. So what does this portray to you? So if you're looking for an angle here, there's an isosceles triangle here. That means we're looking for what this angle is. How do we get this angle? How do we get this angle? Remember we said the angle at the midpoint is twice the angle at the edge, right? So we can come here and see the angle at the midpoint, and we know that this angle is y. The angle, and we have the angle z here, right? You can see the angle at the midpoint is twice the angle at the edge, right? And know this theorem, and know what this means. It means that the angle at the midpoint, y, is equal to twice the angle at the edge, 2 times the angle at the edge. And what's the angle at the edge? 10. Simple. That means y is equal to 20 degrees. Is that simple? That's the law. Right, so how do we find z? It's already a triangle here now. For z, there is already a triangle here. Right? We know what y is now, it's 20 degrees. We can now find z. Remember, this is an isosceles triangle. So whatever is here is equal to what is here as z as well. So what do? It becomes 20 plus z is equals to what? 180. Why? The sum of angles in a triangle. Right, it's 180. So x 20 plus z becomes 20 plus 2z, which is 180 degree. So we know that 2z will be 180 degree minus 20. Haven't connected like terms. This one have to go because you can't add, right? So that 2z, I know if it crosses, it becomes minus. This is an invisible plus. Once it crosses, it becomes minus, right? This 20 crosses to this part, it becomes minus. That's what we're saying minus here. 2z becomes 160 degrees, right? We divide both sides by what? By 2. 2z, which is equals to what? 160 divided by 2. We take off 2. We now know that what? Our z is equals to 160 divided by 2 should be what? Should be 80 degrees. Therefore, we now know that, look at this, we now know that our x is 10 degrees, y is 20 degrees, our z is what? Is 80 degrees. So that's simple. I'm sure you understand all we've been doing in the class. I'll take you on just one more questions as regarding to the second theorem 2 question. So we can jump straight into the third theorem, the second theorem. Follow me guys for the next video. Thank you guys.
Premium Hill Academy. Morality, ingenuity, and excellence at its peak.